Hi everyone, thanks. I'm very excited to be here. Oh, let's start with that one. As a keynote speaker even, and I'm so honored also to represent Philips in this domain. We also have another speaker in the breakout sessions later, which is Imke, and I work also very closely with her. So yeah, we're both very happy to be able to share with you some of the things that we've been working on, and also some of our ideas, and hope to get your excitement and enthusiasm, share that with you. So maybe, thanks for a very nice introduction, by the way, Roos, but I will also tell a bit more about kind of the journey of how I get to work on what I do currently. So I started what was called back then cognitive artificial intelligence at Utrecht. And it was kind of unique when there were a couple of AI studies back then, and they tried to distinguish themselves. So some were more robotics, and some were more philosophy, and so the cognitive part was kind of distinguishing for Utrecht. And then I worked indeed on human AI collaboration and how kind of teams form, and what it means to trust a computer, or what it means to trust a human, and how we can optimize basically working together in hybrid teams. And at the VU, I worked more on using artificial intelligence technique to support behavior change. And then I started to get into contact with more the healthcare side of things, because what we did is we tried to create an app that was using different sources of data and was trying to motivate people to adhere to their therapy, which was often pretty complex because these were patients with multiple, with comorbidities, as we say, so multiple diseases often. So it's like diabetes and depression, for example, or so that was a very interesting problem to tackle, and a lot of learnings from that. But a kind of natural next step for me was actually to move more in that healthcare space. So I started with Philips, and they did something very similar with kind of measuring, monitoring, and motivating people, going more into the solutions and the services space, and not just the machines and like the hardware. So this was a very interesting time, and I think there are so many problems out there that we still haven't solved, right? It's a very exciting area to be in. And then I worked also more in, so my background is also natural language processing for a bit. So there is this app that's Pregnancy Plus that is also a part of Philips. It's a great app, actually. I used it myself when I was pregnant. And I worked there on recommender systems and trying to improve matching the content, personalizing it. So that was more on the personal health side of things. So it's kind of all over the place. But then what happened is that I started working more on diversity and inclusion topic within Philips. This is also something that we as a company, we take interest in. We try to kind of be on the forefront there, including more women, but also people from kind of really diverse backgrounds, making sure that that's a diverse group that we have working on data and AI solutions. And then I was seeing all this news about AI-related problems, actually, and I was thinking, well, this bias problem and this diversity problem, that is actually very particular also for AI. So that's why I'm here right now talking to you about responsible AI. And I really feel, and I think this may resonate very well with people in this group today, that I think we have now so many AI solutions that are off the shelf, out of the box, basically AI as a service, that sometimes I feel people are not even triggered anymore to really consider, what's happening under the hood. Why am I doing it? Why is it even beneficial for the users? So really tackle AI from the multidisciplinary perspective that it is inherently, actually. So this is something that I really believe in, and luckily I see also more pull towards this notion again, and I think that all of you will also contribute to this in the end. So really looking at AI as an embedded service, right? It's not just the user that you're targeting. The user has a context. The user has an environment, and it has barriers and a social context. There's so much to take into consideration if you really want to make sure that your solution is being used in the end or helpful. So why, of the reason why it's important to look at all those things is becomes apparent if you look at what goes wrong a lot of the time. So I think healthcare, again, is a very interesting domain where we can see now that things are being more applied, also we have more visibility on the things that go wrong. There was this study that analyzed all papers that for medical imaging that tried to, from medical imaging, tried to predict COVID, diagnosing or the progression of it. And it actually found that none of those models that were published were of potential clinical use, which I think is shocking, actually, because that means that, well, how to go from there, right? How to go from your maybe more theoretical published results to something that we can implement in our systems that patients can use. So the problem was models are not evaluated on external validation sets, but only on one test and training set. The evaluation is often not done with the clinical stakeholders. It's not about, does it fit your workflow? It's just about accuracy on that specific test set. So these are things that really, we have to look at that, because it's basically a waste, right? If we spend so much time and effort on models that we, in the end, cannot use. So another thing is reproducibility. There was another paper that looked at machine learning in different domains, and it found that specifically for healthcare, reproducibility is very poorly there. And that is, of course, because healthcare has some unique challenges, where data is sparse, data is also often private, so it's very hard to, like I said in the previous slide, we need more validation data sets, okay, but it's pretty hard to get them. There are limited code releases also because companies are trying to protect, of course, what they put into the market. And the data sets tend to be small and noisy. There's no standardized way of collecting data in the healthcare institutes. So all of this are particular challenges for healthcare that we're trying to face, or that we're trying to tackle, but that make reproducibility very difficult. Diversity, of course, there's a lot of talk about diversity in data, and for healthcare, of course, this is very important. So, for example, during COVID, there were these tests that physicians were advised to look at whether the lips of the patients are pale or turning blue or things like that. But those things are for white people, right? So if you test that for darker skins, the symptoms are different. They're different colors, they're different. So just this awareness alone is very important. And that's just on the clinician side, but that data that is then collected, or the way that detection or prediction is being done at the physician side, that trickles down into our data and into our models. And of course, women are also underrepresented, specifically in clinical trials. Women make up less than 30% of clinical trials, specifically for heart failure and coronary artery disease, which really, this can be the difference in life and death, in the sense that women are half as likely to receive proper treatment for heart failure than men, and twice as likely to die 6 months after discharge. So this is because there is just less knowledge around what are the symptoms, how do they present themselves, how can I, because the symptoms are slightly different. And then one type of bias that is actually a little bit more tricky is that proxies are used. So as a data scientist, sometimes you don't have the data that you really need to predict something, right? And you're using proxies. And I mean, that makes sense, but you really always have to look very carefully at what is the implication of that. For example, this algorithm was implemented. It is affecting 200 million Americans. And it was used to flag high-risk patients to see whether they should get additional medical attention. And it turned out that black patients were less likely to be flagged than white patients, even if they were presented with the exact same symptoms. And that was because the proxy that was being used was not actual illness, but it was healthcare costs. And traditionally, black people actually have incurred lower healthcare costs because of different reasons. Either they lived further away from hospitals, or they were less prone to go to the doctor, or there are many reasons for that. But it turned out that if instead of healthcare cost, the medical data was used to predict, then this 18% was bumped to 47%. So again, this is an impact of health. This is people's lives that we're talking about. And the final example of bias is that the loss function that people are using to optimize their models is, there are many loss functions that you can choose, and actually the variability there, or the choices that you're making as a modeler, has significant impact. So for example, there is this model that is really able to predict quite well which hospitalized patients will develop acute kidney failure, but for every correct prediction, they also produce 2 false alarms. And for a patient, this can actually incur additional costs, because there is additional testing for them. They have to come into the hospital. So this is pretty, for quality of life, this is an impact. So these are also things to consider. Now, so Gartner had predicted that 85% of AI projects this year will deliver erroneous outcomes due to bias. That's a staggering number, and I think we also did, within Philips, we did kind of a survey amongst healthcare and healthcare IT professionals, and 93% of those people are actually worried that biases from healthcare professionals or from people programming AI or doing data science ends up in their services. Okay, so I guess it becomes clear that we have some work to do. And of course, there's things that we can do, and there's things that regulation and legislation can help us with. And you are probably all aware of the types of regulations that we're currently talking about. The EU has the proposed AI Act, and it does cover actually some of the things that could help us with these things, like how to do oversight, what is required in terms of technical documentation, in terms of transparency and accuracy, post-market monitoring. So these are actually all things that we, as Philips, also are really thinking about. How can we do this best? How can we serve our customers best? And I want to talk to you about that for a little bit. So these are our data and AI principles. So most of them will sound familiar to you because they were derived from a lot of ethical frameworks that have been published recently over the past couple of years, and the main ones are basically taken up. So you can see things like, okay, of course our focus is on the health and well-being, but then human oversight and this kind of hybrid working as a team it is important for us. Robustness that I just talked about, fairness, transparency. So I will kind of, what I'm doing in my daily job is to kind of try to translate those high-level principles, because they're pretty high-level, right? If you look at this as a data scientist, I'm like, okay, nice, I want to build fair systems. How to do that, right? It's not like a one-to-one translation. It's pretty tricky, and that actually shows also in this movie how tricky it is to really have concrete steps to get a result. Am I getting this right? Yeah.
You're not making any sense. Sorry, you ruined it on purpose.
You know what? I'm hungry. I could really go for a peanut butter and jelly sandwich. Do you guys think you can write down some instructions and teach me how to make a peanut butter and jelly sandwich?
Yeah. I'm done.
Step 1. Get 2 pieces of bread out. Got 'em. Get a butter knife and get some PB. Take 1 piece of bread, spread it around with the butter knife.
No, Dad, with the peanut butter.
I'm just doing what it says. It says take 1 piece of bread, spread it around with the butter knife.
Hold on.
Get some jelly, rub it on the other half of the bread.
No, Dad, open the jelly.
Well, it doesn't say to do that. Put the breads together on top of each other. Take a big bite.
Okay, so really having good instructions on how to do something, that is very hard. And I think for these problems, these are even way more complex, of course, than peanut butter jelly sandwich. So what we're doing is trying to see what are the most concrete tools and kind of best practices that we can implement. So we're looking at how can we measure how well we're doing with respect to responsible AI things? How are we making sure that we are getting the best quality? So things that you can do here is like a maturity assessment of your solutions. There are different phases, like from very ad hoc processes to very kind of state-of-the-art implementations. There are frameworks to assess that. We're doing bias assessments for our data, for our models, and trying to support people in using the right tooling for mitigation strategies. Trying to develop AI quality metrics that reflect really that responsible element. Then in testing, so really looking at that robustness, seeing how can we make it hard for our algorithms, right? What would make them fail? And testing for improvement in their workflow, because that is what the physicians and hospitals in the end care about, that their workflow is improved, not that it's the same. Unless, of course, you're reducing costs, that is also important. But really translating the business goals to the model goals. And this is actually, I think, a lot of jobs will go into this particular area, because it turns out it's pretty hard, actually, to translate your business goal to good model goals. Using A/B testing can be very useful to kind of gradually improve, making sure that you're not doing anything harmful. And then monitoring. This is, the more of our AI solutions come into the market, the more important it becomes to have really good monitoring principles and or workflow in place, making sure that you have the proper documentation. I mean, a lot of companies are, and we as well, we're adopting Agile, and that is great. But we need to. One of the principles there, I think, is like working software over elaborate documentation. And of course, I totally agree with that. You can incrementally improve your software, and then you don't need to write thousands of pages before it's already outdated next week. But what we do need is to have very clear what are the limitations of this software. What is, in what context does it work well? What is in there? So these things, especially if you have a large company like ours, where data moves from team to team, or your model, a team is working on the model, but maybe someone leaves or someone comes from another team. So you have this kind of things that can get lost in translation. So that's why we need really good documentation. And then making sure that there are feedback loops from the user to, basically the teams that are developing the AI to start with. So thinking in advance about what you want to log. I think this is one of the things that is very important. And if you do it after the fact, you're always behind in a sense. So these are things that have to be thought of up front. There has to be an infrastructure for concerns. If your users maybe disagree with where the bucket you put them in for a recommender system, for example, or if they maybe suspect that it is biased or whatever, there needs to be an infrastructure for them to raise these concerns. So also, what I'm saying is that this is also for us a new topic, and we are identifying all these things that we can do, but really making it an integral part of all our solutions is something that takes time and that we're still working on every day. So that is also that last part, making sure that it is in the protocols, that it is in the processes, that people have to adhere to it. That is also something that is very important. So yeah, indeed, like the topic is bias. I worked a lot on this, but I won't say that much about this particular thing, because I know that also we have another speaker, Veronique, who will also elaborately talk about bias. So just quickly, what I want to emphasize is bias is not just in the data. Of course, it's garbage in, garbage out, but there are so many steps in the AI lifecycle where bias can creep in. There are so many choices being made by people like us that can introduce bias as well. And that is what I wanted to emphasize here. And these are just some biases that I checked that I think are very relevant to a company as like Philips working in healthcare. But there are tons more biases, but these are some of the most common ones. Just to show you that, you know, it's not just selection bias or sampling bias, which is most commonly talked about. So what we need, of course, is diversity in people, in the teams, diversity in the types of validation that we're doing, and diversity in data. Again, easier said than done. So what we're also trying to do is create a bias risk assessment. So this is just an example, but I have a lot of people coming to me and say, okay, just give me the top five most influential biases that are the biggest risk. But then I always have to disappoint them because it's so context dependent. It depends so much on your use case. You know, what is like a huge problem for one solution may not even be relevant for the other one. So unfortunately, I usually have to disappoint, but there are checklists, and those checklists can help you to kind of structurally think through the different types of biases that you could be at risk for. And then it's up to you and your colleagues to assess how big that risk is and whether you're willing to take that risk or you need to do some mitigation. Something else that we're currently implementing is documentation, like I talked about before. So we call them data cards and model cards, and they were inspired by IBM fact sheets and Google model cards. I know Veronique will also address this in more detail, so I won't get into too much detail, but what we notice, it's very hard to compare model quality. It's very hard to search, like what can we reuse, what works well, maybe what have we worked on before that we can now adapt for this specific purpose. But then you also need to know what are really the limitations and what should I not use it for and what was it trained on. So these kind of types of documentation really travel with the data. They're in your repository or you link to it, or they're with your code. So that also really helps. So that's something else that we're doing. Now, of course, I talked a lot about what is tricky with AI, but AI can also be a part of the solution. And I think there are so many amazing developments right now. Synthetic data is one of the things that could help us, of course, trying to fill the gaps that we're seeing if you have small data sets or if you have not very diverse data sets. Synthetic data could be a way to leverage that. Of course, you have to be careful not to introduce new biases when you're creating your synthetic data. But definitely this training on a mix of synthetic data and actually and the collected data has shown to improve also accuracy and robustness. There are great tools currently, and every month I think a new tool becomes available on the market on how to support with explainability, how to support with bias detection. You have, so TCAV, for example, it tries to really look at what is contributing to the outcome of your prediction of the model without putting it in literally. So these classes that you can see here on the slide, like being male or not, those were never actual features in the model, but kind of implicitly the model has constructed these concepts. So that's very insightful. You definitely should check that out. And then how to check that our models are safe and robust. I think this is one of the topics that we will have so much more. We need to create so much more knowledge on how to make our AI models secure if we're putting them on the market. And these are also things that you kind of can attack your own models to see how robust they are. There are different methods for that as well. Very cool. So what I want to spend the last couple of minutes on is talking a little bit about sustainability. I think this is a topic, we all know that data is taking up a lot of, storing data and cooling data is taking up a lot of energy. We know that ICT services will take up like 40% of emissions, I think by 2040 or something. It's now 2%. So there will be like an enormous increase. And AI can actually help us, but also can do harm. So there are kind of two topics. One is AI for sustainability, and I think Renata will also talk about this later. So that's how can we use AI to do good in this respect. So you can have like telehealth to reduce traffic, or you can make sure that there's equal access to care, or predictive maintenance. But on the other hand, you can also implement your AI in a way that is more sustainable, that takes up less resources, that it's more optimized, that you're using maybe smaller models. This becomes important because these models grow exponentially, as we have seen in the past, and it comes with a price, like literally, if you train it in the cloud. And so this was for, if you look at the number of parameters in the models and then also the training time it takes, and the corresponding energy use, it's like, so yeah, this is the same picture actually, but then a different scale. So you can see, this is continuing this trend, right? So we really have to start thinking about what are the trade-offs here. So there are trade-offs. So you can use maybe a smaller model, and then it takes less energy to train. But maybe then you have to do more on application side. So that is a trade-off. Or you could say, like, from a fairness perspective, I need more data and I need retraining in every domain. But then from sustainability side, you have kind of a counter, like a negative effect. So there are lots of considerations here that that people will have to start thinking about pretty soon if we want to make a sustainable impact. Now my time is up, so if you have an interest in this, look up green coding practices, very interesting domain, things that everyone can already start using. So final words, I think it would be good for all of our AI applications and solutions to have kind of this label that says, in a way, like how, at least if it's only internally, but I think for the user and consumer, this will also be very interesting, but how is it doing with terms to responsible AI elements? So in the end, AI comes with responsibility. Whose is it? Like, everyone likes to point to other people, of course, but basically it is everyone's responsibility. Even the persons who are developing AI specifically, who are not doing the coding. You are responsible in a way because the business goals have to translate it to the model goals. You have to start thinking about the trustworthiness of your product on day one. You have to think about that feedback loop I mentioned. So every one of us is responsible. Oh yeah, these are some questions that you could ask yourself to that aspect. So I think that's it, yeah.